Good morning, everyone. Myself, Yash Vyas. I am a student of IIPS DAVV, currently studying in fourth semester, MTech IT. Today, I am going to present the solution of internal 2 of numerical analysis and design assigned by Professor Saligram Prajapat sir. In the first question, here we are given the data of the census of different year, uh, and we have to identify the current population of year 1925, 1975, and 1984. Now we have created the forward difference table for the above data, and we can, as we know in forward difference, we always take the values from the upper column, and while in the backward difference, we use the values of the lowest column of each row. Now we are computing the value of u, in which we will take the first a minus the second value divide by the h. So the u comes out to be 0.4. Now by applying the formula of forward referencing interpolation, we get the value of the year 1925, that is 36.75. Now for the 75, as 1975 comes in the ending or in the last, so we use the Newton backward formula, and the values which we will be using are from the forward table lower column values, and then for the u we will take the last second year value minus the last year value divided by the h, which comes out to be 0.6. And after applying the formula of Newton backward interpolation, we will find that the estimate value for the year 1975 is 185.56 for, and now for the last year 1984, which is outside the table, we will be using the external interpolation method, where we will find the u value through the uh, we will find the u value using the value which we have to find minus the last value divided by 10, which is h. So the u's come out to be 0.3. Now the estimated population for the year 1984 comes out to be 239.44, and if we think and if we take for uh, thousand for a million, it comes out to be 2 lakh 239 comma 440 peoples for year 1984. Now the question number 2 has started. In this we have given a two-dimensional table, and we have to find the interpolation using the 2D table for the value of f of 2.5 comma 3.5. Here in this 2D interpolation, we take the adjacent values of the given targeted value, so and take the average of that, and that's come out to be our answer. The formula for that is 1 by 4 divided by summation of all the adjacent neighboring values. In this case, the neighboring values are f of 2, 3, f of 3, 3, f of 2, 4, and f of 3, 4. Then we will substitute the values of that f of x, y in the given equation. Then the final value of the interpolation of 2.5, 3.5 comes out to be 47.5. Now in the question number 3, we have to use the Simpson's rule to find the integration for the given data, where the x and the f of x values are given as the following. Now we are using the Simpson's 3 by 8 rules, where the h value we can calculate by subtracting two adjacent values of h. So the h comes out to be 0.3, and n must be the multiplication of 3, where n is the numbers of value given in the table. Now we are using the formula that for Newton's 3 by 8, which is 3h by 8 y0 plus yn plus 3y1 plus y2 plus y4 plus y5 plus 2y3 plus y6. And after substituting the above values from the table, we will get the value of integration as 2.8875. Now, in the question number 3, we have given the following equation, that is 2x square cube minus 3x square plus 4x minus 5. And we have to integrate this value in the interval of -2 to 4, where a is equals to -2, b is equals to 4, and taking the value of n is equals to 4. We are going to solve this uh, integration using the Lagrange's Gauss-Legendre formula, and we can solve it using 3-point or 4-point or 5-point. Here, if we take the 3-point method, the values of W1 is this 5.5556, W2 is 8.889, and W3 is equals to W1. And then same goes for the coordinates of x. Here the x coordinate is minus 0.8386113, and x2 is equals to 0.3399, and so on. And the coordinate of x3 is equals to minus of x1. And same for it, if we take the 4th point, there will be W1 is equals to 0.3478, so on, and W2 is equals to 0.6521 4515, and W3 is equals to W2, and W4 is equals to W1. And the coordinates of x1 is equals to minus 0.86113631, and minus 2 is equals to 0.3399810, and x3 is equals to minus of x2, and x4 is equals to minus of x1. And for the third, if we will take the third 5 points, then the following are the values of w1 and x and x. And then after choosing whichever point method we are using, we can find by elevating the value of f of 4 and evolving the value of f of -2. Now, if we will be taking we can substitute the values in this equation, and to find where the f of x is equals to this, and f of 4 is equals to 76, and f of -2 is equals to 34, and the exact value is equals to 72. Now, question number 3. In this question, it is asking us to write a code or a flowchart for the Newton forward difference interpolation formula, and here we will write the code for it. Now in this code, we have written a C implementation of this Newton forward interpolation formula, where we are firstly taking the integer values like I, j, and n, and the float values like x and y, where the x is a 1D array which will take the 20 values, which can take 20 values, and y is a 2D array which can take a matrix of 20 cross 20, and h and u and sum and p and fact is equals to 1, and the final is the value to find. Then we will print, enter the points, and then scan the values. Initially we are initializing this, we are not taking in and input the int and float values, and we are taking the value of n as the input. After doing that, we will use a for loop from I is equals to 0 to I is equals to less than 1 at the steps of 1, and we will take the input the values of the xi and the y I0, the matrix. After that, we will use another for loop from j is equals to 1 to the j less than n, and for I is equals to 1 to I is equal to 0 to I n minus j at the steps of 1, and we will create the and y of I comma j is equals to y of I plus 1 j minus 1 minus y of I j minus 1. From this loop, we will create the table, Newton forward table for the following question solving. After that, we will enter the interpolation value by the value will be taken using the scanf. After that, we are initializing the value of h, where using the x of 1 minus x of 0 value. After that, we will compute the value of u, which is value which we have to find minus the x of 0 value divided by h. And then we will initialize the value of sum, which will be y0 comma y00, and initialize the value of p, which will be 1. After that, we will use a for loop from I is equals to 1 to I less than n in the steps of which is p is equals to p into bracket u minus I minus 1 bracket close, and through which we will be and after that we will calculate the factorial. Fact is equals to fact into I, and then we will calculate the final sum of that, that is sum is equals to sum plus p into y of 0 comma I, which will give the upper row values of y using the 0 comma I, and then we will divide it by the factorial, and through this last loop we will be getting our final solution for the formula of Newton forward interpolation. After doing that, we will print the value of sum, which is our answer.